Hello, everybody. So we're getting started just a little bit early today. This is going right. So I have been surprisingly excited to get to work on this. So we had the numpy stuff that we did over the weekend, and uh, we got some really good results. So for people who weren't watching last week, yeah, so David, it was great. So we set up some stuff to do fuzzing of NumPy. Basically, we created a generative fuzzer to go through and generate functions for the most part and test everything in NumPy. And I think within 2 minutes of so we built a test harness first to do in-memory fuzzing of Python functions. And then we built a generative fuzzer, and probably 2 or 3 minutes worth of fuzzing, we got our first crash out of NumPy. It was unfortunately just a null deref, but it showed that things actually worked. Like we're actually generating and finding real crashes now. So I left that running for a while, and for one, it completely trashed my system. It turns out one of the functions we were calling would coerce the object you passed it in to a string and then write a file with that. And that caused all sorts of problems. It took me actually a fair amount of time to try and fix it. But we got a ton of other crashes. So I haven't gone through and triaged any of these, but in I think about 2.5 hours worth of time, I got over 1,000 crashes. I have no idea about uniqueness or anything like that. And unfortunately, these are all a little bit difficult to read through. So the way like all these logs are we have a looping buffer, and then we have a series of functions that looks something like this. And in this case, we were on 22. So this right here is supposedly a function that caused a crash. No idea how that is, and unfortunately the format that I'm logging all these out in isn't very conducive to logging them. But what's super exciting to me is this actually worked. We found real crashes. However, I missed one very important thing. So I was going over this after the fact and looking through some of the code, and I realized we actually can't find the vulnerability I started all this with. So originally we were talking about how we'd be able to come in here. Is it? No, it's not on here yet. Medium, Python. Nope. That one. So when we first started doing these, I guess actually last week, when I first started talking about this though, the plan was to write a fuzzer that would be able to find this bug right here. If you create an array, you resize it to something very large, and then you access it, you'll be able to trigger an out-of-bounds read and an out-of-bounds write too. And this was just I'll post this in the chat yet again. This was just a bug that some guy doing some bug bounty searching found. And I think he found it through... Oh, that did not do what I wanted it to do at all, did it? Edit. That. Oh, sorry. I'm having some problems with my copy and paste. There we go. Anyway, so this was just some guy. He was doing work to find some bug bounties, and he found this crash. Awesome. Great work. But unfortunately, the way that we're currently doing fuzzing, we cannot find this. And the reason we can't find it is because in order to find this, we need to call the resize member function on the numpy arrays object. And even though we're getting crashes right now, we can't get this crash because we can't resize an array. We can just, I posted the link. Why is it doing that? Oh, apparently every time I highlight something on this page, it copies it. Thanks. But anyway, um, we can't ever call a member function right now. So the first thing I want to do is go back and fix that. Add that in, and hopefully be able to find these crashes. I also want to fix up how the test harness works, because right now it's pretty janky. The logging is absolutely awful. I want to get some of that fixed up. There's a few other things I want to do to make the test harness a little bit more usable. For example, right now, we're not getting any metrics on how many test cases we're getting. So currently we're getting, I was discussing this with somebody this morning, and I don't have a example if you land on popen. So a question in the chat is how to fuzz a scripting language without damaging the OS. For example, if you land on popen. There's a couple different ways that you could do it. The way that I'm doing it is I just don't care. If I trap, so I'm doing, all of this is in a VMware VM, and if I trash it, I've been meaning to blow this VM away and start over anyway. Or what I'm going to do, hopefully we have time for it tonight, is actually move to an EC2 instance. And if we trash an EC2 instance, again, I don't really care. There are things you could do. For example, one of the things that are really good ideas are do things like set up a file system so that, just as an example, we could set up a chroot that's on a read-only file system. So you're never going to be able to write to it. Or on a RAM disk. So it's fine that it's there, you'll be able to read and write to it, but whenever we kill that chroot, it's just going to go away. It'll be non-permanent. I suspect chroot is probably the easiest way to handle the issue you're talking about. But for the most part, I'm not sure I care that much. It's gonna, so the best example is this fuzzer that I'm using right now. It wrote a ton of objects onto the file system, and I just cleaned them up. I deleted all of them, I got rid of them, and I don't really care that much that they were there. But there are solutions if you want to do the sysadmin stuff to try and fix everything up. So, I think it's about everything. I guess before I kick things off for real, there's one more thing. Ooh, so David is suggesting using overlayfs and a chroot. I've never actually tried that. So I've heard of overlayfs, but I've never actually used it. Overlayfs. So overlayfs is a file system service for Linux, which implements a union mount for other file systems. And you're able to have like two different file systems that do things slightly differently. I've never tried it, but that sounds like a great idea for how to do it properly. So David mentioned it in the chat. I'll see if I can come up with something that actually talks about doing it. The under file system can be read-only, and then you mount a temp read-write file system on top of it and chroot into that. And that sounds like a great idea. So, like I was saying, before we get kicked off for real setting up this fuzzer, one thing that people might be interested in is that the RCTF, or Rios CTF, is this weekend. Or Royos, I'm sorry. I've been saying it wrong this entire time. This is one of the XCTF competitions. Those are the... So they're international, it's an international league of competitions, but they're mostly run by various Chinese groups. I don't really know what to say other than it's a league that's been running for a while now. They've been doing a great job of making them better and better. I'll probably spend a fair amount of time this weekend taking a look at this, but this is coming up this weekend for people to be aware of. After this, there's a few other CTFs in the near future. There's Faust in a few weeks. There's going to be a few others throughout the rest of the month. Looks like we're going to be able to get into things. So I am not going to do anything with confidence. I can't go to the conference. It's in person in Poland, and that is a very long flight away for me. So I'm probably going to spend that time just working instead. So yeah. So let's see here. We talked about CTFs coming up. We talked about what we're going to do. I think that's about all that's important right now. Oh, if you haven't seen it yet, this works, right? Pretty sure this works. So, where is it? Oh, I guess maybe he only posted it in Slack. So there's a video for, oh. See if I can find it real quick. So there was a discussion about live CTF stuff, and there was a video of people playing CTF, but I can't seem to find it now. That's unfortunate. If you're interested, there is a video of people play. Oh, no, I want that. There we go. I'm trying to fix all my windowing so that I can get different chats and actually read it while I'm doing things. But there's a video of some live CTF stuff. I'll see if I can find it after the stream and tweet about it again. There's also a cool post from Trail of Bits, which you saw there before I killed it. There's this post from Trail of Bits about using Manticore. They went through, and if you remember, 2 weeks ago, I tried to solve the Magic DEF CON CTF challenge with Manticore, and it completely broke. Apparently, we go all the way down here. Salio contributed a fix that I was running into and having it break on me. They've also got this challenge. If people want to give it a shot, it's basically they put together a challenge executable to try and write some Manticore scripts to try and solve quickly. So this is definitely an interesting post if you're interested in doing that. But yeah, there's the messed up sound one. It's not great to watch, but I do think it's one of the few examples I know of watching people from, yeah, this is probably the one. Let's see if I can copy and paste this real quick. YouTube.com. Is this gonna work? Yeah, so this is, as far as I know, one of the only examples of watching people of head-to-head live CTF stuff across multiple teams. So I know there's been a number of groups that have posted like in different members of one team playing CTF challenges against each other, but the challenges across teams, being able to compare the way DEFCORE looks at something to the way LCBC or PPP or Zero Day Sober looks at things. There aren't many good examples that you can directly compare different teams looking at things. I find that really interesting because there's a habit of when you're watching, so when you're working with a team, you learn a lot from each other, and when somebody learns a cool trick, it's a lot more likely that everybody else picks up on it. However, people on different teams don't necessarily have that same level of sharing, so you get to watch different approaches. And right here is a good example of it, right? You can see these are 4 different people, all of which are, well, I haven't watched all of it yet, so I don't know what the order is for when they landed, but all of the teams doing this are very good at solving ponables, and they all have completely different approaches. So you see PvP is over here with hex rays up, and they're renaming things. DEFCORE is looking at, what is that? They're trying to reverse a function a little bit. Over here, LCBC is looking at a completely different function, and they've got the Python console up, so it's quite possible they're running some analysis. The 0 Day people are looking at yet another function. It's really interesting to be able to compare those across teams and try and compare and contrast different techniques for how you go about it. A good example is, and I'm Not entirely sure if that's in this one or not, but the approach of should you reverse out structures or functionality first? Um, I don't know which ones are more efficient, but I do know that the techniques I use, my team members tend to use too, because we kind of learned them all together. However, the techniques that I use and somebody from DevCore uses are going to probably be completely different. We have a completely different history of how we learn to do things. So, in any case, that's enough of a little bit of rambling there. I think videos like this are fascinating to watch people do things, and it's a lot of the reason why I started doing streams like this, so that while I don't get to watch other people do it, at least other people can watch me do things and hopefully learn something from the way that I'm approaching problems. So, yeah, if you get a chance, I would definitely take a look at this. It's super interesting. Yeah, I think it's about everything. So, let's get to work here. The first thing we need to do, I guess let's just jump right into it. So for people who didn't watch the Saturday stream, our fuzzer has a few different basic parts. So there's this C-types object, or we have this function, some C code we wrote to do the basic parts of our test harness. And this is super simple. We're basically going to, it gets initialized, it sets up a page that's going to be separate from everything. We're cheating a little bit here and using the way the malloc arenas work to get it away from anything else in the libc malloc. We then, for every test, we copy it in to that buffer, and we set up a signal handler so that if we ever get a seg fault, we're going to dump the past 32 iterations out to a file, save it off, and then exit. Relatively simple, and the idea is basically just to get things set up so that we can catch crashes. So we have that, and the other major part is this test harness. And this is also pretty simple. So this is, we just load up our C-types object, we initialize everything, we just loop through, we generate a test case, we register that test case. So the tester.test registers that, so it knows to save it off if we catch a crash. Then we exec whatever that function is that's been returned. And you'll notice here this, oh crap. I have some stuff going on in the background. Give me 2 seconds and I will be right back. Okay, sorry about that. Yeah, unfortunately, I have a habit, if I forget to turn it off, I start up my machine, I get ready to start streaming, and if I forget to turn it off, it's very nice and helpful, and it gets ready to sync any of the backups that I have. And that causes a ton of problems when I'm trying to do things that are useful. So that's off now, and we should be ready to go. But one thing that's important here about how we're setting up these actual test cases is we've imported the numpy module, and that's the only thing we're passing in as a global to the test case. And that's just because we don't want it to mess with any of our global functions. We want just that one module. Yeah, so that's that. There's also this gen. So gen.py is how we're actually generating our test cases. And the first thing we're going to have to do here, so I guess to step through this real quick to explain what's going on. When we initialize it, it goes through, it finds all of the functions, anything that is callable in the numpy module. It adds it to an array called callers, and it also sets up some basic types. Hello, people who are just tuning in. And the basic idea is that when we go to generate a test case, we do this, we set up this imp. The INP is an input that we're generating. And we just go through, we randomly get something out of the callers list. We set up everything to make sure we're able to call it properly. Then we pick a random number of arguments between 0 and 5 arguments. We then add those arguments to it, and that's it. We return that string. And that's what, if you remember, we have. So if we go into crashes, crash 7, yeah, that seems fine. So it generates a string something like this right here, where this was the actual caller that we picked. And it picked np.sign, and it looks like it picked 1, 2, 3, 4 arguments, 3 of which were some sort of complex module, or some sort of complex object, and the 4th one was just a -1. And we've also seeded this with a few test cases. So we have all of these arguments that are just normal types we might want to pass in. 1 character, 256 characters, 4096 characters, 0, some integer values that might be magic, an array, a dictionary, and a set. And just because those are things that might do something. That's it. That's all. So that's all this fuzzer is. We just randomly generate this stuff and pass it in and see if it causes crash. And that's why I was a little bit surprised that we very quickly were getting crashes, because all in all, this is a relatively simple fuzzer. It's similar to some of the very early on JavaScript function fuzzing stuff. And what we're doing isn't all that advanced. We're doing no code analysis. We're not even we're completely black box fuzzing these functions. And it turns out it works. So with that said, I think it's probably a pretty decent overview of what we're doing. I do want to start with knock this down. So there were some issues. I was being a little bit dumb about it, but this is going to have us add things a little bit more commonly. And what's important here is, so we have the callers.append these. And let me think about how to do this properly. So one thing that's unfortunate is we don't have a good way to get things out. The first thing we need to add in, so Philip, currently I'm not uploading this code, mainly because if we do, so I'm a little bit concerned that we might stumble across something that just completely breaks everything. So like, I don't know, there's some terrible, like if we came across some terrible Python bug in the process that was like remote code execution in anything that was running Python, I would not want to have that, like I would feel very bad about having released code that somebody just turned around and had that just work. So in the future, after we finish this cycle of streams, there's a decent chance I'm going to release it. But at least right now, I don't want to make the mistake of releasing some major bug live with there's no time for anybody to get things fixed. And for the most part, it's relatively simple the way that things are working. And what I think is more important is actually the process here that we're using. Because realistically, we're fuzzing numpy, and if I can run arbitrary code on numpy objects, there's not much of a security risk there. What's more interesting is the process, generating these functions, creating a fuzzer, creating a test harness, and translating that to other things. I think is a lot more interesting than this specific code. So hopefully the concepts are more interesting than the results we get. At least that's the theory. So after we're done with all of these, I may or may not release it. It kind of depends on the way things look and what kind of crashes we get and things like that. But for now, it's just what's on stream. So that's that. So what do we need to do here? What we need to do, and let's actually test this out real quick. So import numpy as np. So let's see here. If I have a is equal to np.long, a is equal to np.long complex. So a creates some object. That's a yeah, there's some complex 256, whatever this thing is. We want to both have that, but we're also going to need to call dir on it. And we need to take all of these things and add them as additional functions we can call. What's the best way to do that? So I think, so one of the problems is that we're using this exec here, and this is kind of gross the way that we're dumping things. We're basically creating this out, we're appending things. So, you know what? Let's just do it the gross way. Out.append plus caller plus no /n out.append dir plus caller plus that. Right, so we're going to exec whatever we use to define this thing that returns a new class. We're going to append how to create that class, and we're also going to append all of the functions that are called it by it. So we have ret, which is the thing that creates a new object that we haven't seen before. And we also want to have new callers is out1. So we did that, and we also want to do for func in new callers. That should return the list over on the left. We want to callers.append definer, comma, caller. So caller is going to look like inp underscore, it's going to look like this. We want to append that plus dot plus. No. We want to do if. What's going to be a good way to do this? So we only really want to do the callable ones. We're going to have a lot of crap if we try. So, for example, if we... What's a good example? That's a function. That's a function. That's a function. Oh, come on. Seriously? Is this just a bad example? So we're listing all the members, which a.bytes. There we go. And this is a int, right? So if we did a.n bytes 0, that is always going to fail for us. So what we really want to do is we want to do a list comprehension like we are down here, and we're returning that instead. That code is going to look gross, isn't it? Type function will work. So what we want to do is we want to filter this to only the things that are callable. So let's do that real quick. I in... This is actually getting completely unreadable. Plus filter. Okay, so filterer, let's do this properly, is well, let's call it something reasonable, obj for obj in dir %s if callable get matter Yeah, this will work fine. It's going to instantiate a lot more of the objects than I really want it to, but I think I'm okay with that. percent caller, comma, caller. So what we're doing here, right, is we're going to do a list comprehension, and we're saying for every object in dir caller, so we list out all of the things like dir a. We're going to list out everything like this, and for every one of those things, we want to return it in this list comprehension if we can call it. So there's this callable function, so we can do callable a dot t. That's false because a dot t is a int, and a dot n bytes is also an int. So callable a dot n bytes is going to fail, like it's false because it's not a callable object. And we're using getAttr because object dir returns a list of strings, not the actual object. So we use getAttr to do it. The unfortunate part here is that we're going to instantiate this a lot more times than we strictly need to. But I think I'm okay with that. I think for the most part, I'm probably okay with us instantiating an object a lot of times. You know what? Let's not do that. Because for some of these, the instantiation might be very heavy. Let's just actually do this. We've done that. Caller is equal. Caller. And caller is equal to plus caller plus that. So we instantiate this thing once as a caller. We append that to what we're dumping out. We also append the filterer, which is going to loop through and do it like that. And we can actually use the same object every time. So now we're only instantiating this thing once, and I feel a little bit better about that. So if that works, I think it probably works. What we should see is we should see a lot more interesting crashes, I think. Oh, we actually have to use that, don't we? So we have the new callers. So for function new callers, we want to do callers.append definer, comma, caller plus dot plus func. I think it's right. Whatever it's doing, it's having some problems with. I was hoping we'd get a crash pretty quickly this way. It's possible that, oh, there we go. Look at that. Ooh, move, crashes, hold, make dir crashes. Let's run this one more time. That was nice and fast. So we having crashes, this nice crash. And let's actually look at this over here so I can actually see it. CD crashes, this crash. So we are on 22. Oh. So yeah. Okay. I can tell by the pixels that it's a hack. Yeah. So we can see that this worked better, right? We're actually calling fill now, which is a big improvement. So we're now we instantiate this, which is a core coefficient. We instantiate that with a whole bunch of arguments. So we pass in, what is that? 2 to the 32 minus 1, a int 32, another int 32, and what is this? I don't know. So in any case, we're actually like we're filling it with a view which was called with a list as who knows what this code is doing, but I think it's totally plausible that this is causing a crash and that it works. Um, so that's awesome. This is doing what we want. So we have, if we go back over here, so we have added the member functions. Let's fix up our test harness a little bit before we go on too much farther. The other piece that I wanted to do real quick is, so if we look at this code, this is our test harness thing. The first and most important thing I want to do is, hello, I want to fix this code. So currently we're dumping out everything in that loop, and that's messy, and I don't like the way that looks at all. What I want to change this to do is, let's just go through and do it real quick. So let's get rid of all of this. We don't care what we're currently on, because we're going to start at iter, and modulo 32 does not equal iter -1 modulo 32. Right, I think it does what we want. So we're going to loop through. We start at iter, because we're handling a special case here. If iter is 0, we need to, that's why we're modulating by 32. And we want to loop through and dump all of them out. And I think if we do it this way, it should just work. We don't need to sprintf this anymore. That. Sure, that looks right. Python test harness.py. Oh, that's unfortunate. Well, that clearly did not work out the way that I wanted it to work out. It would appear that our handler is causing issues for us. I is equal to iter. We increment it in the modulo by that works. Oh, duh. I is equal to I plus plus. Nope. Insert there. There we go. That's much better. So we were incrementing it and moduloing it, but we weren't we're gonna need to make. That looks much better now. Come on. One thing that I've noticed, and I'm not sure what's causing this, there's some things that seem to hang, and they're just not doing anything. It's probably worth trying to triage this at some point. Like this, not proper behavior. Jeez. Here, yes. X Python kill 20. Yes, there we go. Yeah, see, we created this A object, and like I don't know what an a.npy is. It's some sort of like internal numpy object. Like looks almost like they pickled it somehow, and we create a whole bunch of these as we're going. And my guess when it hangs like that, oops, that's not what I wanted. rma.npy is that it's actually like having file IO or something like that. Any warnings? That's a good question. Ours I have no idea what that error is. RCU schedule kthread starved. Yeah, I have no idea what that error message does. Oh no. Is our code still not working right? That's unfortunate. Oh. And there's that too. We might have just trashed all of our, No, we still have space. You can see it's dumping out data now. Kill all Python. Go away. So for whatever reason, kill all these. So why is this code not doing what I want it to do? So let's think through what I want it to do real quick before we do too much. So if iter is currently 0, then I want to go from I is equal to iter, because iter is going to be the next thing we're going to try. So when we crashed on is iter minus 1. You know what? I can just print all these out and I is equal to I plus plus modulo 32. I think that's right. I think that looks right. And we want to loop. Okay. You know what? J include watchdog to reset the process for scalability. Yeah, so we've actually got a wrapper that is really bad but works to reset things that we're not using right now. I'm just trying to get things tested real quick. 32 J plus plus plus. Why is my equals key sticking a little bit? Okay. I is equal to J modulo, or iter plus J modulo 32. Because this code, I know, does what I want it to do. This is me going, you know what? I might not be the best at writing C, but I can hopefully find some crashes with it. So one thing that I realize you can't actually see here is it's hanging here for a second. I'm going to control C it, and I bet you, C message, we have another one of these. And I don't, we'll wait for this thing to actually do something. Go all Python. Oh, that's nice. As soon as I, oh, look at that. We have a crashes function. And if we do vim that, currently on 17, that seems fine. And this, assuming that all the code works. Oh, let's change one more thing real quick. It's still open, isn't it? Yeah, it's still open. Print. So I want to have this print out that we're currently on that. So it's going to be a string now. And C types make Python test harness.py. Okay. So if we go into crashes, I should be able to do. Oh, you're going to do that to me, aren't you? Move crash.func.py Python. What? Oh, That's me being dumb. Global NP is not defined. Import numpy as NP. What I'm hoping for here is that I should be able to just run Python as, I should be able to just do Python this thing, run it. Well, that didn't cause a crash. You're supposed to cause a crash. Oh, because, st, actually, how do I use fputs? And it's a file, not a, I can't use that. Unfortunate. Yeah, we'll just do it this way. This is really gross, but it... Oh, no, 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 don't do that. Don't do that at all. Sorry, I held down the wrong button. Okay, so here we are. So I want to write each of these cases in a try except pass. Except /n pass /n/n/n, and that is 14 characters minus 5 is 9. Sure. Write fd comma try /n, and that is 5 characters. Make sure that's right. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, I was off by a lot. Hit control plus slash. Okay, we did all that. Let's also change this to be a .py. Okay. We're going to recompile this again. Crashes. We're going to remove all of these. And Python test harness.py. Kind of do like the so for people, since I guess there's a number of people that are not American viewers, so when we're fuzzing there, I'm humming the Benny Hill theme song. That is Benny Hill. That's I guess it's British, isn't it? But there's a whole, it was from the 80s, and he would constantly get chased around, and his theme song would go. Anyway, so that's what I'm doing, and it's just me being dumb. So, anyway, we have a crash now. Unexpected indentation. Okay. Oh, crap. Yeah, this isn't going to work. You know what? I was hoping this would be easier to do, but we're just going to do it this way. /c types. Python test rm crashes /star Python test harness. We're getting rid of all that. We're just going to go in here. And it fails. Fine. We can come in here. We can probably go and delete all that. So presumably, this should And if we go into crashes, cannot cast that. Huh. So one of two things is true here. Either I'm messing something up, or, well, let's add that code in. That code is easy enough to write. S printf st comma print percent t slash n. Q cd c types make on test harness. Okay. And we want to do Python crash that one. End of line. Not good. So for whatever reason, it looks like we somehow like truncated something. Unfortunate. Fuzz more, right? If you don't get the results you want fuzzing, the answer is, at least some of the time, to fuzz harder. Come on. We are now waiting for jiffies. So while we're waiting for our jiffies, what did we say that thing actually was? Yeah, sure. There we go. Yeah, see, we're creating all these extra objects now, which, I mean, ideally I would fix it so that isn't happening, but at least so far, nothing major has happened that makes me care. And that was the one we wanted. So we're currently on 14. Oh, why are we not printing? Oh. Duh. Well, that's me just being dumb. We want to print out which one we're on. Clear all that out again. And as soon as I pick up my glass, that finishes every time. Okay. Python crash. We got another one of these. Why is that happening? So clearly we're like stripping out a new line under certain situations, and I suspect the reason is we're supplying like some very long string. Oh. I wouldn't be surprised if that... No, that's not. Oh, let's look and see. So what I'm curious about here is how long is this? 3, 4... Yeah, okay. So if our string is too... Oh, I didn't even think about that. So we're passing in this very long string. There are cases where that might be longer than the 2000 hex bytes we've allocated for that. We only allow for 2000 hex bytes. I'm trying to think of which way I want to fix this. I think the way that I want to fix this is we're just going to get rid of this one. We're going to make this much smaller. And hopefully, so my hope here is that us cutting it down in size that much doesn't matter. But there are definitely bugs we can't find now because I did that. I don't know if any of those exist or not, but it is quite possible that there are bugs we cannot find now. Ooh, that's new. So one thing that's worth noting is, so we got a floating point exception, which we actually aren't catching right now because we're only handling seg faults. That crash just went away and we did not catch it at all. But that's good to know because our previous fuzzer could not find those, or at least it probably couldn't. Which means we're doing better now. Yep. PD crashes. What do we have here? Okay, so currently on 9, and on the very first one we caused a problem. Oh. He crashes. Edit this, so Oh, nope, that totally worked. Sorry, I apparently I'm printing out the same thing twice, but that looks different. Eh. There's a certain amount of you know, it crashed. I'm not sure how much I care. So we have a sig v on Python dict get item. Okay. And RSI, yeah, there is no way that is what it wanted to be doing. So we are comparing RSI against like RSI plus 8, which is probably some form of a null deref, and that EB is some offset into a struct that was then copied around before it was accessed. And like we're trying to access a sub element of that. But yeah, look, like this function rate, like this as a test case is fascinating to me. So we initialize a uint32 with a long as its initialization. I think that's probably 2 to the 64 minus 1. We're then going to return that uint32 plus 2 to the 64 minus 1. We're then going to have that as type a array. So not as type array, we're calling as type with an array. We're calling datetime64. And what's actually causing our crash is so 26 is datetime64. We're calling clip on that with whatever this thing returns. And that causes a null deref for some reason. Or something similar to null deref at least. So yeah, that's a fascinating crash. So that works fine. That logging, I'm not thrilled with that logging, but it works out okay. Like it's kind of janky, but at least it's not too bad to manually take care of. So we have that. That kind of works. We wanted to add some general test harness improvements, which we implemented several of those that I had for that idea. Is there anything else immediately that I want to do? I kind of want to get rid of some of the handling, but I think I'm okay with this. So, cd ... git status. Oh, there is one more thing I want to do. So the wrapper. So I mentioned this a little bit earlier. We have this wrapper, and this is absolutely, completely gross. So as a way to loop everything, I was just going to run this. And this is not exactly what I want to do. So we clean, that works fine. Let's think about this. The things we want to add to this that are not currently being done are, 1, I don't have the slightest clue how many test cases we're getting per second. Like I have no metrics about how much fuzzing I'm doing. I just know I'm getting crashes. And I'd like to add that in. However, before I add that support, you know what? This works. Oh, wait, no, let's, we want to do SSH EC2. So I have an EC2 instance that's set up here. It's ready to go. It's awesome. Yes, we're going to kill that. Let's push all this stuff up there. So we need to give it C types. Actually, you know what? scp-r python ec2 Oh, you're copying all of the. You don't need to copy all of those up there. rm-rf python. I always feel a little bit nervous when I do stuff like that. // move crashes. So like rm-rm python makes me super nervous because it makes me think like, oh no, am I accidentally going to delete the system Python or something? Because on a couple of cases I've done stupid things like that. One of the things that I do in CTF that like when I'm testing an exploit, I'll do rm core python exploit like this. So I'm going to remove a core file if there is one, and then I want to run some exploit script that's going to work locally, which is fine. But if you miss that semicolon, this deletes my exploit. And I've lost so many exploits that way on accident, where I've accidentally deleted it because I missed that semicolon because I was tired and playing CTF and didn't catch it properly. So we have this. Let's first sudo apt-get install make. The one thing I dislike about doing some of the stuff on EC2 is this is a fresh image, so there's all sorts of stuff that isn't set up properly. Make. This failed. GCC not found. Sudo apt-get install ZZ. Nope. Yes. Sudo apt-get update. Python-numpy. Okay, so we have a test.so. We want to make dir a crashes Python test. Before we do that, let us screen. So we're now screen inside of screen, which I'm sure is great. Awesome. This looks like it totally works. And I want to do while true do Python test heart are we're doing that. That's unfortunate. Kill all SSH. That should have worked. Over here. That worked fine. We're going to do a watch. Again, this is awful and bad, and if you were trying to do things for real, you should not do it this way. I want watch dash. Where is it? Watch dash n 200 Kill all Python. Yeah. And now we have what is a terrible, bad, awful fuzzer and test harness. So this sits here, it runs every 200 seconds. We're going to kill all the Python that's running. And the idea is that if there is a crash, it will automatically restart because we're in that while loop in bash. And we will also kill everything and restart it in case we get hung. And the timing for this, I have no idea if any of this timing is correct. Like, I'm just guessing 200 seconds because that seems like a reasonable amount of time. So what do we have? Like, we're definitely spitting out crashes here, which is awesome, right? Like, we're totally getting what I'd like to be getting. So, we're doing all of that. Trying to think of what else I really want to get done today. Like, it's really awesome that we have stuff working. You know what? Because this is actually running faster, I'm gonna drop that timeout. So every 60 seconds, we're going to kill all Python. I think a minute worth of fuzzing is enough. And again, we're losing some test cases because of this. Like, there's definitely long-running things that are perfectly fine to do, and there are bugs we could not possibly find because of how we're killing things. But I'm okay with that. Like, the fact that we're still getting crashes, even though we're doing things so poorly, it means I don't need to fix them. What's the saying about that? Perfect is the enemy of good. That I know I can fix a lot of these problems, but in the 4 hours we've been working on this, we've been able to find tons of crashes. And I would rather have it working and getting crashes than spending a whole bunch of extra time to make it better and not getting crashes. So, man, I'm really curious what that is that keeps spewing by like that. And unfortunately, we don't have any good way to find out what that is. This is this is just standard out of all that Python. Like, it's printing something to the screen, but I have no idea what that is. It's a little unfortunate. I'm a little curious what that is. But it's always fascinating to watch a fuzzer and see what it's doing. So, um, yeah, like, we're just spewing out crashes for us to look through. And at some point, we're going to have to go through and actually triage all these, figure out what kind of crashes are happening where, do things with it. 7FF3. Like, let's take a look at this one real quick. We are currently on 13. So if we come down here, ooh, that one's complex. Wow, that's actually quite complex. So we came in here, Python, crash, FF. Did I do that wrong? Oh, I need to save it. Duh. Oh. I do that. Right. Crashes. Well, it doesn't do anything, which is kind of what we expected. Print 12. Hmm. Hmm. Oh, you know what's happening here? I bet you that at some point we're combining things here like that. Hate when I pick a bad one. Let's try this one. FE. So currently on 19. / print 18. That looks nice and simple. Python crash 7f fed. So nice, doesn't it? Thanks, EC2. apt get install gdb. Do bang bang. Yes. I do love when I run, like, why on earth would you want GCC on a server? And again, I do understand why I probably don't want it. That's interesting that that's the exact same crash we looked at before, isn't it? That's a little unfortunate, right? So we're, in the same case, we're trying to pull stuff out of a dictionary that is not initialized. Well, at least it works for now. Let's see here. What else do we want to do for now? We have things working. I don't have the logging that I want to have working, but that's okay. Actually, let's go look at the list that I made. We have an EC2 instance set up. We don't have the RAM disk set up like I wanted to, but I think we're getting plenty of throughput that I just don't actually care that much, right? Like, there's some definite improvements that would give us more input. Like, we'd get more crashes, but we're already getting, what's this been? We're already getting 6 unique crashes a minute. If we sit here and let this run for, if I run this overnight or I run this until Wednesday, we're going to have thousands upon thousands of crashes. So I don't know how much I care about the little improvements because we're going to have to triage this and go through them anyway. But yeah. I'm thinking that it might be about time to call it an evening. And a little early again today. Let this fuzz for 48 hours or so. Hopefully have some nice results for Wednesday to start digging through. Then on Wednesday, we can write some code to triage these crashes, classify them a little bit, and hopefully pull things out. Let's actually talk a little bit. I guess we can do that real quick. So triage.notes. We're going to have several steps for that, right? So write GDB triaging. So we can just be basically the same thing we did with the PDF crack stuff. So just a very simple consume one of these crash logs that we have. And I think the best way to do that is we're just going to read. We'll just take that last couple functions and see if that causes the crash. Ooh, no, the way we could, okay. And that's going to be create Python to consume crash logs and repro. Run in GDB to classify. And we'll just classify it by PC. So what is a program counter at time of crash? And we can, let's just assume that any unique program counter is a unique crash and just go from there. That isn't necessarily true, but it's a good enough place to start with, I think. Then triage them all. Go through whatever crashes we have, classify them all, categorize. This is a different indentation level. Categorize PCs. Categorize by function. One thing that's unfortunate, and that I'm a little bit concerned is going to be the result here, is if almost all of our crashes is because there's some pathway to create a dictionary that doesn't actually get initialized, which is entirely plausible, right? Like there's some initialization code that we're somehow skipping over, and it's just a nullity ref because a dictionary isn't being initialized right. So even though it looks unique, so we looked at one that looked unique because it was date times 64, and then this most recent one was, what was it? Like calling any on a rint object, an rent. Like I don't know what any of that's doing. It's calling compress on it, and it's somehow causing like a dictionary not to get populated properly. Now, it's also entirely possible that, so this other object is a view. So both of these are related to a view somehow, so maybe a view is the problem. I'm a little bit more okay with there's some bug with views not initializing right. But in any case, we're going to have to triage it and classify both on the Python code as well as PC and try and get something out of that. And hopefully, I mean, we've got 39 now. Hopefully we'll be able to come back in a couple days, take a look at these, have some sweet crashes to go through, and we can go from there. I think the plan will be, I assume on Wednesday we're not going to get super far. Like probably write the triaging stuff, get it kicked off, let it go. But I don't really expect to do much as far as analyzing those results on Wednesday. I think it's mostly going to be, we have these, we're working on them, we're going through and classifying them. And then probably the following week, so not this Wednesday, the 17th, but the 24th, we'll actually go through and try and land some of these, because hopefully at least one of the crashes we have is going to be an exploitable bug that we can get some memory corruption bugs out of. So that's the plan, at least. And again, like always, if anybody have, if any of you have questions or comments, feel free to message me either here on YouTube or on Twitter or on any of the Slacks or on IRC. I'm on Freenode with this as Murmis. I'm also on a couple others, I think Hackent and I don't know what else. But feel free to message me if you have questions or comments. Just let me know. Also, if you enjoy the videos, there's quite a few more. So if you want to go back and watch them on Saturday, we did about 3 hours of building all this from scratch. And hopefully the explanations were relatively useful. On Saturday, we got a lot of people asking questions about why am I doing things a certain way, and I got to talk through a lot of that. So if you're interested in some of the whys here, I kind of ran through at the beginning of the stream today what we did. On Saturday, I went a lot more in detail about why it was done this way. So why am I doing in-memory fuzzing? Why is the signal handler in C as opposed to a Python object? And we talked a little bit about that. Although, I mean, like always, if there are questions about that and my explanations are not clear, feel free to message me, say something, and I'm happy to try and explain more. Other than that, I think we're going to call it a little bit of an early evening today. And I will see everybody on Wednesday in about 48 hours, and hopefully we're going to have some sweet crashes to go through and hopefully find some cool bugs. So thanks everybody for tuning in, and I will see you all later. Bye.